Hello, students. How are you? I hope you're very well. So, finally, we are moving to the third chapter of geography theory. Already, two chapters we have completed. Chapter from the fundamentals of physical geography, chapter 1, and India physical environment, chapter 1. And from practical introduction to maps, we have already completed. Today we will discuss some interesting topic, the origin and evolution of the earth. From 7 to class 10, you have particularly studied different concept of universe, solar system, planets, asteroid, meteoroid, etc. But in this chapter particularly we will focus the reasons behind that origination, that how the universe originate, the vast universe that we used to see, the endless universe. What is the reason behind how it originate? This kind of important and very interesting question we will try to find the answer from this chapter. So the origin and evolution of the earth, I divided this chapter into two parts. That is part 1, origin. We will focus in the concept of origin in part 1, and part 2 we will focus in the concept of evolution. So let's begin the journey. First question, Twinkle Twinkle Little Star. It's a very common poem you have heard. Okay, so from childhood, since childhood, you have heard this poem in nursery rhyme. It's very famous. So, starry nights have always attracted us since the childhood. You may also have thought of these stars and had numerous questions in your mind. Questions such as, how many stars are there in the sky? How did they come into existence? Can one reach the end of the sky? This kind of question we usually ask, that how the universe formed, what are the beautiful stars are there, how many stars are there, how they originate. Okay, maybe many more such questions are still there in your mind. In this chapter, we will learn how these twinkling little stars were formed. With that, you will eventually also read the story of origin and evolution of the earth. So, in this chapter, not only will study the concept, but also will try to find out the proofs that yes, this concept can be applied for the final interpretation, that like this way our planet originated. First concept, there are two types of theories. One is the early theory and second is the modern theory. So early theory, origin of the earth. A large number of hypotheses were put forth by different philosophers and scientists regarding the origin of the earth. Many German philosophers, many English philosophers, they've put forward a lot of concept that how our solar system originate or how our earth originate. Still we don't know the perfect, interpretation or a logic that how our earth originate. But there are many hypotheses. Hypothesis particularly means what? A set of assumptions. A set of assumptions with some proof, with some basic proof, a set of assumption. So many philosophers, many mathematicians, they tried to give their proof or assumptions. Yes, like this way the universe formed. One of the very important philosophy or the hypothesis is known as nebular hypothesis. One of the earlier and popular argument was made by a German philosopher, Immanuel Kant. Immanuel Kant uh, propounded a hypothesis known as nebular hypothesis. Later on, this nebular hypothesis has been reinterpreted, revised by mathematician Laplace in 1796. So what is the hypothesis or the assumption? The hypothesis considered that the planets were formed out of cloud of material associated with a youthful sun. That means Immanuel Kant imagined a space, a empty space with clouds. Clouds means what? Dust particle. Okay, all the small dust particle colliding with each other, and due to collision, they are generating heat. They are generating light, as well as they are generating rotatory movement in the universe. So when the small particles comes together, they are creating a little bit bigger particle, and more bigger particle. Such kind of particle we used to say sun, a youthful sun, which was slowly it's rotating because it contains heat, it contains light. So in this video we can see this concept that, see, this is a cloud, dust and cloud particle. You can see this cloud particles having lot of particles in them, this cloud, and they are coming together, colliding together, making more solid, okay, making more materialistic. So after collision they all make doing rotation and all in this empty space, and they are coming together. So from smaller collision they are making bigger collision, from bigger collision they are making much bigger collision. Like this way a giant trap of heat is forming in the in a place of universe, and it slowly started rotating like this way, and smaller particles comes together, and it making the entire it making a star, it's making a formation of a star. Like this way you can see a primitive star, or a concept of a primitive star has been propounded by Immanuel Kant. Okay, this concept is known as nebular hypothesis. So it's a one of the interesting concept, nebular hypothesis. Next, we are moving to the early theories of the same part. That one of the important concept of nebular hypothesis. After nebular hypothesis, in 1990s, in the later 90s, Chamberlain and Moulton considered that a wandering star approached the sun. Suppose from the nebular hypothesis, what Immanuel Kant propounded, we have seen a formation of star. We have seen a star. It is rotating in the blank universe. It is rotating in the blank universe. So this wandering star, Chamberlain and Moulton approached it as a sun, or the father planet, or the father star in the universe. As a result, what happens when this planet started rotating in a full speed? When this planet started, or the star started rotating in a full speed, it becomes a elongated in shape, and slowly what is happening in this elongation, the particles coming out from this father figure, from this father star. As the passing star moved away, the material separated from the solar surface continued to revolve around the sun, and it slowly condensed into planets. Just imagine a high speed moving circle. Just imagine that. Okay, so from that circle what is coming out? Small particle, because it is in semi solid in nature. So all the semi solid particles coming out from that thing, and they are also circulating the father star. This concept later on elaborated by Sir James Jeans and later Sir Harold Jeffrey. They supported this agreement, and they given the name of this concept as a binary theory. Binary theory means what? Binary means one. That means one means what? At the initial stage, they have an assumption that there is only one star, and from that one star, slowly, all the stars and all the planets formed. In 1950s, Otto Schmidt in Russia and Karl Whisker in Germany somewhat revised the nebular hypothesis, though differing in details. They considered that the sun was surrounded by solar nebula containing mostly the hydrogen and helium, along with what may be termed as dust. That means what? They imagined that initial stage there was a father star, that is a sun or a youthful sun, and it's surrounded by dust particle. The video that I have shown you just right now, it's surrounded by dust particle, and slowly when this in the cloud, from the cloud, the atomic particles started colliding. They generate heat, they generate light, and they generate rotatory movement. This friction and collision of particle led to the formation of disc-shaped cloud, and planets were formed through the process of accretion. So through the process of accretion, these things has been evolved. Okay, so just revisit this video once again. Just imagine this is a cloud, and you can see these clouds are coming together. Just see, round, so atomic particles are coming together, and they are generating. Solid particles started evolving, and smaller particles also joining the bigger particles. So these bigger particles in the universe, they colliding with each other and joining with much bigger particle. Okay, so like this way the our first star or the youthful sun has been formed. As all the things comes together, the movement becomes very much faster. Okay, so when the movement become very much faster, a lot of particles come out from the sun. That's all about the nebular hypothesis. I hope the concept of nebular hypothesis is clear to you. Next, we are moving to the concept of Chamberlain and Moulton, and this is the image, the cigar-shaped concept that they have given. Okay, the cigar-shaped. This is a cigar-shaped concept. This is known as cigar-shaped extension concept with proof. So from smaller to bigger then smaller, so it creating a cigar shape in the universe. Okay, it's a proof of Chamberlain and Moulton concept. So this is an example of particularly the concept of early theories. Now we will start the concept of modern theories, that how modern theories evolved and the origin of universe. When you discuss about the concept of modern theories, the most popular argument regarding the origin of the universe is the Big Bang theory. It is also called expanding universe hypothesis. Edwin Hubble in 1920 provided evidence that the universe is expanding. As time passes, galaxies move farther and farther apart. You can experiment and find what does the expanding universe means. Take a balloon and mark some point on it to represent the galaxies. Now, if you start inflating the balloon, the points of the marked on the balloon will appear to be moving away from each other as the balloon expand. Like the same way, the universe also expanding. Okay, as in a balloon where inflating air, inflation is taking place, the balloon is expanding and all the points are also expanding. Our universe is also behaving in the same way. Similarly, the distance between the galaxy is also found to be increasing, and thereby the universe is considered to be an expanding. So whenever you used to study astronomy, astrophysics, you used to say that our planetary movement, whatever the planetary movement is there, it is not fixed. That means if I say the distance between the sun and earth, the distance between the moon and earth, we used to say, but it is not fixed because our planetary movement is dynamic in nature. Okay, so the difference between the galaxies is increasing, sometime it's sometime decreasing. Okay, so this thing we can say that our universe is expanding in nature. However, we will find that beside the increase in the distance between the point on the balloons, the point themselves are expanding. So not only the galaxies are expanding, but also the shape, the size of the galaxies are expanding. This is not in accordance with the fact. Scientists believe that though the space between the galaxies is increasing, observation do not support the expansion of galaxy. So the balloon example is only partially correct. So the balloon example is only proof that that our universe is expanding, but not the galaxies are expanding. Okay, the galaxies having a same size, we don't have proof yet that yes, our solar system is expanding or not. We don't have yet proof, but the universe is expanding. It is expanding in nature. Okay. Many a times in modern theory, whenever we used to study the concept of Big Bang theory having three important stages. In the first stage, in the beginning, all matter forming the universe existed in one place in form of a tiny ball or a singular atom with an unimaginably small volume, infinite temperature, and infinite density. That means a small singular atom started moving in the universe. Okay, at the early stage. At the Big Bang, the tiny ball exploded violently. They led to a huge expansion. It is now generally accepted that the event of Big Bang took place 13.7 billion years ago, before the present. The expansion continues even to the present day. As it grew, some energy was converted into matter. There was particularly rapid expansion within fraction of second after the Big Bang. Thereafter, the expansion has slowed down within the first 3 minutes from the Big Bang event. The first atom began to form. That means what? When the single tiny atomic ball is expanding, it's exploded, and with the explosion, small particle formed. And when this particle form, they also collide with each other, forming a huge Big Bang. And in the entire universe, in everywhere, we can see the atomic particle, which is moving, which has its own heat and light. Within 300,000 years from the Big Bang, temperature dropped to 4500 Kelvin and gave rise to atomic matter. The universe became transparent. So this is a fundamental three stages of the Big Bang theory. So let's see a video that how it has expanded, so we can have a clear-cut idea from this. So here you can see the dusty cloud and the father star, that is our youthful sun. So when the sun is revolving, all the clouds, the particles of the clouds are also revolving, because as it is radiating energy. Collapse of particle taking place. Particles are collapsing with each other, and they are generating numerous heat and light in the universe, in the space. Okay, so you can see small planets started forming in this place. Okay, and when they're growing up, they're coming together because they're having gravitational attraction. So small particles, they're going to the big particles, and like this way, huge big size of stars they used to form. And at the initial stage, what happens? They used to collide. This is known as the Big Bang. Okay, Big Bang. And when they after collision, again all the particles started coming towards each other, and like this way this process continues. Okay, disruptions of volcanic eruptions taking place, formation of thunderstorms and all, dusty sulfur clouds they used to form in this era. Okay, so we can have a look again in this video. Please see the video once. This is the first stage of nebular hypothesis that you have covered, and later on, slowly by slowly, we will proceed to the concept of Big Bang. Okay, so you can see here the dust of cloud, and in between the youthful sun. It's generating huge amount of energy in the universe. So particles started coming together, and many a times gravitational forces also acting. Okay, generating of gravitational forces. Like this way, stars formed, and finally what happens? Two big stars, they collide each other and generating huge amount of dust in the universe. Okay, so you can imagine this is Earth and this is Moon. This is the concept. Okay, so this is the concept of Big Bang. I hope it is clear to you now. Next we will move forward. So there are the two theories we have covered, the early and the modern. Okay, next part we will move is the conclusion. What we will study? The expansion of universe means increase in the space between the galaxies. An alternative to this was Hoyle concept of steady state. Hoyle was one of the very great scientists. He propounded a concept of steady state. This is not important now. In this part 1 video, we will discuss the concept of Hoyle in part 2. It considered the universe to be roughly the same at any point of time. However, with greater evidence becoming available about the expanding universe, scientific community at present favors argument of expanding universe. Okay, so in the next part 2, we will understand, when we will study the formation of planet and star, we will understand the concept of Hoyle and the expanding universe. So in the next class, we will understand the concept of the formation of planet and star. So there is a very thin difference between a planet and star. We will understand. I hope you know the difference between planet and star, but in the next part we will understand it very scientifically. Next we will understand the concept of our solar system. Why this planet are forming like this? We will understand this concept. And finally the concept of evolution of Earth. That how the Earth, the life evolved in Earth. This concept we will study. So that's all about the concept of this chapter. I hope you have understood. I'm making it very simple and very easy to understand. Okay, so early theories, origin of the Earth, Immanuel Kant, and nebula hypothesis. Please refer your NCERT book. After that, we have completed the Chamberlain and Moulton cigar-shaped concept and the binary theory. That we have given a proof that yes, there is a concept of youthful sun at the very primitive age. Okay, very essential. We have seen this image also there. In the modern theories, we have seen the Big Bang theory concept and the three stage of Big Bang formation. And we have seen this video. And finally, we have concluded this first unit of this chapter. Your homework is to revise the theories as it is very important, very vital. These YouTube video links I will give you, animations, you can have a look from there, that all the ideas will be clear to you. Okay, thank you everyone. Thank you so much. And part 2 lecture will be more interesting because we will apply the concept of these theories, okay, in part 2. Thank you so much. We will meet in the next class. Take care.